Okay, let's give you guys some more practice. So here I've got a weight. I've got a weight hanging on a wire, and this wire here is attached to the ceiling here and here. So this angle here is 55. This angle here is 40. Well, if this is 55, then this must be 55 because two parallel lines. So remember, whenever you have two parallel lines and then you have a straight line, you have a straight line. If this angle is 55, then this must be 55, and so on. So work out the components for this force, work out the components for this force, and work out the components for this force. So press pause and have a go. Okay, so to do this, focus your mind onto this central point. So the whole system's in equilibrium. So the force pulling it to the left must be equal to the force pulling it to the right. So the force pulling it to the left would be you using this right angle triangle here. It would be the magnitude of this. It would be the magnitude of this, and then times cos 55, and then pulling to the right would be you using this right angle triangle here. So it would be the magnitude of this times cos. So it's really you working out this distance here, and then so this thing here represents this distance, and to the left represents this, and then looking at it vertically, pulling down must be the same as you pulling up. Well, pulling up would be you looking at this, well, looking at this vertical force here, and then you looking at this vertical force. Well, this vertical force here would be the magnitude of this times sine. Remember, sine is this thing here. So sine, well, this whole thing, this vertical force is given by this. This vertical force here is given by this. So adding the two pulling up bit must be the same as the thing that's pulling it down in the opposite direction. So now that you're here, you can solve this. This is like your simultaneous equations. So solve this. So rearrange this. So f1, the magnitude of f1 must be this thing divided by cos 55. So f1 here equals this thing here. So now we can put this whole thing into f1 to work out f2. So this is us solving simultaneous equations. So putting this thing here into here, that will then give us, and then when you times this, it will then give you this whole thing here, and then f2 sine 40, this. So that will then take us to here. So now f2 is the only thing that we don't know here. So we can just work it out. So hang on. So looking at this, let's merge these two together to give us 10, to give us this block here. Okay, and then now factorize out the f2. So that will then give you this. That will then give you this. So now divide both sides by this bubble here. That will then give us this. And then so the magnitude of f2 is approximately this. So from here, jump to a calculator. That will then give you this. So now that we've got f2, we can put this into f2 here to work out f1. So putting this into here, that will then give us this. So now you've got your cos 40, cos 55, and so on. So f1 equals this. So now going back to the very start, we now know the magnitude of f1. The magnitude of f1 is this. We've just worked out the magnitude of f2. Remember, it's the magnitude we've worked out, not the actual vector. We've only worked out the magnitude. Well, anyway, the magnitude of this is this. The magnitude of this force is this. So from this, we can work out a vector. So now that we know the magnitude, pulling it in the left direction would be a negative, and then pulling it to the right would be a positive. Pulling up would be positive, this thing here would be negative. So looking at F1 in this direction, it would be our magnitude. It will be our magnitude times cos 55. Cos 55. So this thing here represents this arrow here. Represents this arrow here. Would represent this arrow here. But because we're putting it to the left, we need a negative. Now this thing here, if we want to know the horizontal component of f, sorry, let me go back one step. Now still looking at f1, we now need to look at the vertical. Well, the vertical would be this, okay? And the looking at f2, looking at f2, horizontally it would be this. It's in the positive direction, so it's going to be plus here. Here's a negative direction, and then vertically it would be this. Well, anyway, this thing here goes into here. 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 And by the way, this thing here going down, your weight would be represented by this. It would be 0 horizontally, but then because it's going downwards, it would be negative 75. We don't actually need this, but I'm just trying to illustrate it to you. Okay, so this here would be your final answer.